NASA's Spitzer Space Telescope has given astronomers clues about the sizzling climate of the peculiar exoplanet 55 Cancri e, which is twice the size and 8 times the mass of Earth. Astronomers have gleaned some puzzling information about an Earth-like planet located 40 light-years away, in the constellation Cancer. Their rocky exoplanet 55 Cancri e, twice the size and 8 times the mass of Earth, revolves so closely around its parent star that gravitational forces cause a year-long orbit to speed by in just 18 hours. By studying data collected by infrared light sensors on NASA's Spitzer Space Telescope, astronomers from nearly a dozen institutions around the globe have calculated that the temperature of the exoplanet's two hemispheres vary by more than 2,000 degrees Fahrenheit. One side is a scorching 4,400 degrees Fahrenheit, while the other is a cooler 2,060 degrees Fahrenheit. What's behind the extraordinary temperature discrepancy on 55 Cancri e, recently dubbed Janssen in honor of Dutch telescope pioneer Zacharias Janssen? Some temperature differences expected, given Janssen's tight orbit. Gravity keeps the planet and its sun in a tidal lock, just as the moon is locked to Earth, which means that one side of Janssen is permanently facing its star, Copernicus, and thus baking in its heat, while the other remains perpetually cloaked in darkness and is much cooler. But the hot side is hotter than the sun, like Copernicus can account for. The latest findings tell us the planet has hot nights and significantly hotter days, said Bryce Olivier de Murray, an astrophysicist at the University of Cambridge, England, and lead author of a paper on Janssen's puzzling climate conditions published March 30 in the journal Nature. This indicates the planet inefficiently transports heat around the planet, he said in a NASA announcement. In their paper, Dr. de Murray and his colleagues suggest that maybe Janssen has an atmosphere only on one side, or maybe no atmosphere at all. On a planet such as Earth, the atmosphere traps heat that wind circulates around the globe to keep temperatures stable. The half-atmosphere hypothesis could help explain another surprising finding. Janssen's hottest point is not directly in the middle of the Copernicus exposed side, but rather shifted about 40 degrees east. If there's no wind to push the heat around, they argue, maybe molten lava is responsible, flowing east across Janssen's surface. The day side could possibly have rivers of lava and big pools of extremely hot magma, but we think the night side would have solidified lava flows like those found in Hawaii, said Michael Gillen, a paper co-author from the University of Liège in Belgium. Solid lava cannot circulate heat, which would explain the cooler conditions on the exoplanet's dark side. The researchers calculated Janssen's temperatures by studying how conditions on the surface changed throughout its orbit around Copernicus. To do this, they analyzed 80 hours worth of Janssen's orbital data collected by Spitzer, a nearly 13-year-old NASA space observatory that captures the infrared light emitted by celestial bodies. Exoplanets emit infrared light as well, which Spitzer can capture to learn about their atmospheric compositions, NASA explains on its website. As an exoplanet orbits its sun, showing different regions of its surface to Spitzer's cameras, changes in overall infrared brightness can speak to the planet's climate. A decrease in brightness as the exoplanet then goes behind its star can also provide a measurement of the world's temperature, NASA writes. This allowed the researchers to create a thermal map of the planet. Janssen has been extensively studied since the super-Earth was first discovered in 2004, and has at different times been thought to harbor a planet-wide ocean, diamonds in its inner layers, and an atmosphere of hydrogen, helium, and cyanide. But the paper's authors now believe that its surface is almost completely covered by lava. We haven't yet found any other planet that is this small and orbits so close to its parent star, and is relatively close to us, so 55 Cancri offers lots of possibilities, said de Murray. We still don't know exactly what this planet is made of, it's still a riddle. These results are like adding another brick to the wall, but the exact nature of this planet is still not completely understood, he said. NASA says that in 2018, Spitzer's more sophisticated successor, The James Webb Space Telescope will launch into space and allow astronomers to look at Janssen and other exoplanets in much more